So hello everyone, I'm Ashutosh Dhikne. My student Shenik is really the lead author. So any questions you have, I can punt saying that, hey, I don't know as the first author. Uh, what I'm going to discuss today is IntruSense, an enhanced physical security system using UWB. I'll make a small correction to my introduction. This is a UWB based technology, not really wave, and we will look at the differences in a few slides. So let's get started. And I also need my phone here to know how much time I'm consuming, because I can go on, you know that, right? Faculty can typically consume any amount of time that is given to them. So physical security is a multi-billion-dollar industry. We know from various estimates that it spans somewhere between $40–50 billion to $140 billion based on what all you include in physical security, whether it is just home-based security or security for museums and other large spaces, etc. And lots of companies are involved in this business. It includes SimpliSafe, ADT, Cove, Vivint, Footprint is a new one, sorry, Frontprint is a new one, something similar, and so on and so forth. But what tools do we have at our disposal? Well, most physical security today is about trying to install magnetic sensors at the doorways, ingress-egress sensors. So you open the door, you know that the door opened. Motion sensors based on infrared waves. What are these sensors? Well, they just emit IR signals. And when there is some disturbance on the IR signal, you know that there is somebody present, there is a motion in the room, and you detect that, and you turn on an alarm. And the most pervasive really are the cameras, which can look at an indoor room and tell whether somebody has entered, somebody is doing something that they shouldn't be doing, etc. However, there are a few issues that we need to deal with. First of all, most of these systems are all room level coverage, right? Each of those systems is only covering one room. They are kind of obstructed by walls and doors. We therefore need multiple expensive devices to be installed in any indoor space, in a home, for example. Further, each of those devices will also be triggered by a friendly. What do I mean by a friendly? Friendly is something that is supposed to be in the space, such as a pet, an elderly person, or even the museum's guards, for example. These are friendly entities. They are supposed to be there in the space, but our physical sensors would get triggered by their presence. Further, when we talk about cameras require a large amount of data processing and require large bandwidths. So it's not easy to have large spaces covered when you don't have good Wi-Fi connectivity, for example. Now, here is our goal. We want to change some of it. We can't change everything, but we want to change some of it. We want to have a wireless system, a system that would cover an entire indoor space, such as a full home. It should be inexpensive and easy to deploy. And we want to use low amount of data and bandwidth, and still, with all of these features, also allow a friendly entity to be able to roam around in the house. Right? And how do we do that? Well, we want to do that through a wireless sensing approach to physical security. So instead of using vision, or instead of using cameras or IR sensors, we want to use wireless signals. And that's where this paper comes in, which is titled IntruSense, an enhanced physical security system using ultra-wideband. Here is the core intuition. We have this large indoor space, relatively large indoor space, and there's a wireless transmitter somewhere in the middle of the space. A wireless transmitter is sending out signals in all directions. Now, these wireless signals bounce off of walls, furniture, and a lot of other things, and then they return back. When they come back to us, we can understand the pattern of those reflections. And so long as this pattern can be maintained, we can actually say that there is nobody occupying this indoor space. So the reflections that we get, they describe something called as the wireless channel's impulse response. It's as if an impulse was sent out by the central transmitter, and we got multiple echoes, multiple responses back from the indoor environment. Now in our tests, if we send out a wireless signal, the echoes that we get is based on the actual physical environment. Where are the walls? Where are the furniture entities, etc. And since there is nothing moving, we essentially get copies of the echoes in the exact same manner. We get a repetition of the same pattern again and again. This is what is shown on the right-hand side. There's a black line there. I'm not sure how many of you can actually see it all the way back to the room. But there's a black line that shows the average channel impulse response. And the red individual lines are actually showing how similar the individual channel impulse response is over time. It doesn't change much over time. So we observe a static reflection pattern. Now, if there is a person that comes into this room, the reflection pattern changes. It's no longer an unoccupied room. It's no longer an unoccupied indoor space, but there are now new reflections that are going to be caused by the presence of the person. There will be first order reflections, which is directly reflecting from the person, as well as second order reflections, third order reflections, and so on, where there is signals reflected off the person, then reflecting off another wall, and then reaching back to the transmitter. What is the impact of having all of this? Well, now the channel impulse response no longer matches the average channel impulse response that you had before. So by looking at this deviation from the known channel impulse response for the unoccupied space, you can start to say, maybe there was an intrusion in this indoor space. Furthermore, if this person starts to move, then the channel impulse response continuously changes as well. It's not just deviating from the average channel impulse response of the unoccupied space, but it's also continuously changing. So you have this movement which causes the pattern of the channel impulse response to change over time. Putting all of these things together, we should be able to use the changes in channel impulse response to detect intrusion. That is our core goal, and we try to achieve it. However, while this sounds simple, there are a lot of hurdles that we need to overcome. First, wireless signals travel at the speed of light. What does that mean? It means that distinguishing reflections from different walls is not like standing in the mountains and talking with the mountain and you get echoes after some time. Right? You essentially have to have a mechanism which is able to distinguish between reflections that are coming at nanosecond level granularity. Nanosecond is a billionth of a second. That's point number one. Point number two is we need a technology that can actually cover a relatively large indoor space. And what options do we have? Well, we have options about wave, we have possibly Wi-Fi and UWB. And there are trade-offs between which one we can use in this particular scenario. In addition to all those, we also need a mechanism to ignore disturbances from known entities. Right? Some disturbances are bad because they are caused by intrusion, but some disturbances, like the ones that will be caused by an elderly walking in the house or the pet, need to be distinguished from that intrusion. Therefore, we need a mechanism that can give us localization of those friendly entities and a way to subtract out changes in the channel impulse response because of these friendly entities versus that from the intrusion. Right, and we are going to focus on this one particular technology, which is UWB. It allows us to have large coverage, very similar to how we have one Wi-Fi access point that can cover an entire house. Wave wouldn't allow us to do that because wave gets obstructed by walls. It also has a wide bandwidth, a 1 gigahertz bandwidth actually, which provides us the nanosecond level channel impulse response that we need to distinguish between very close reflections. Further, UWB also allows much robust localization, partly because of that 1 gigahertz bandwidth with 1 nanosecond channel impulse response being able to distinguish. Right? But what is this ultra-wideband? There's a lot of confusion around UWB, and that's why I have a couple of slides to just introduce this particular technology. But ultra-wideband is ratified by 802.15.4a and 15.4z standards. This is, in some sense, a personal area network standard. UWB uses 500 megahertz to 1 gigahertz bands in the range of 3.1 to 10.6 gigahertz. They use very low power, minus 41.3 dBm per hertz. Further, UWB, very different from mmWave, actually has very low data rate at 110 kbps, 850 kbps, and 6.8 kbps being the only three possible options. But they provide long range. They provide an indoor range that goes beyond just one room to about 50 to 70 meters based on how much metal you have, for example, in the indoor space. And this happens because of two reasons. One, we are allowing for a very low data rate, right? So you can have larger symbols, and you are allowing the receiver to have higher sensitivity. And it can provide you very low error in terms of bit error rate. Okay, contrasting this with what UWB is not is also important because of some confusion that has been created very recently, which is this. Well, the mmWave based ultra-wideband that Verizon wants you to all to know of is a completely different technology. That's just an advertising gimmick. What they are showing basically is, yes, a larger bandwidth, but not 1 gigahertz. It's only about 200 megahertz or so, but that provides you a much faster internet connection, much higher data rates. That's not the technology we are talking about, because at the mmWave level, you will face obstruction by walls and obstruction by a lot of indoor objects. Okay, having clarified all of this, let's go back to IntruSense. By the way, if you feel confused about all of this, you're not alone. There is a CNET article about that confusion as well. Okay, where is UWB used? Well, it is already there in Apple AirTags, smart tags by Samsung and Samsung mobile phones and so on. And there are two alliances, the UWB Alliance and the FIRA Alliance, where there are various companies who are collaborating to understand what the standards should be with UWB, etc. Google, in fact, is also working on API for Android mobile phones. Okay, so innovations in IntruSense. Well, there are 4 models that we propose. One detects directly the line of sight, another one disturbances in the reflection patterns, the third one ignores movements of friendlies, and the fourth one tries to create a single central radar system, which you should be able to deploy in the center of a house. Let's go quickly over the first one. Well, here is the idea. You have 2 UWB devices. They're exchanging information between them. This is known as a poll, response, final 3-message exchange, which provides you a means to calculate the distance between the 2 UWB devices. When you do not have any obstruction of the line of sight, then the distance measurement between UWB devices is going to be very accurate within few centimeters. Whereas when we have an obstruction, the signal that actually goes from UWB1 to UWB2 is obstructed, and all we are going to see are various reflections from the environment. And therefore, you get very different distance measurements. Those are actually the distance measurements of nearby reflections, including the reflection from the ground, for example. Right? And therefore, anytime an intruder actually crosses through the line of sight between these 2 devices, you will get a different distance measurement between the 2 UWB devices. That could be one means of understanding that somebody has intruded into a space. A product of this sort, for example, could be put across a doorway, and you would be able to count people entering. You would be able to tell whether somebody enters in or not. The second model starts to detect reflection patterns. So you have more UWB devices now in the environment, 3. They are exchanging data between each other. But then when there is a person or some intruder who is nearby, there is reflections happening from this person. Those reflections disturb the known channel impulse response, and we can see a very clean, clear deviation from the average channel impulse response, which can be detected, and we can infer that there is an intrusion. Now, how do we ignore the movement of friendlies? This is interesting. Right? The question is, can we arm this security system when the space is already occupied and yet detect when there is an intrusion? Right? And here is where you would want it. You would want it if you have pets at your home, or there are elderly people at your home, or in a museum where there are already guards who are actually going to move around, right? And still you want to detect when an intrusion happens. All of these use cases are impossible to do using IR motion detectors, cameras, etc., because you'll continuously get false alarms. I'm overdoing the animation here a little bit. But the friendlies, the solution that we propose is let the friendlies where a UWB device. Now, since UWB can inherently do distance measurements and localize, you can actually tell where this pet is in the indoor space. Once you know where the pet is, you know how the channel impulse response would be disturbed because of the presence of the pet. You can ignore the part where you know that there will be disturbances and only focus on the part where there should not be any disturbances in the channel impulse response. At this point, if there is an intrusion, there will be disturbances in the earlier part of the place where the CIR is still aligned, and then you would be able to detect that an intrusion has occurred. So this creates interesting possibilities, but it's simple to summarize. All that you want is any few entities inside the indoor space which are friendly, such as the elderly, or the museum guard, or the pet, could wear a UWB transmitter receiver, is actively being localized continuously by the UWB system inside, and any changes in the channel impulse response which do not correspond to the location of the friendly are going to cause an intrusion detection alarm. The fourth one, which to some extent is still work in progress, is basically a system which uses a radar using UWB. Right? What is this system? You place 3 UWB devices in the center of this entire indoor space. One is a transmitter. You get 2 receivers. By understanding the difference of time between the 2 receivers, you can tell where the friendly entity is, as well as you can detect an intrusion. There is, however, an important problem. When you have 3 UWB devices so close to each other, you will have leakage of signal from the transmitter directly to the receiver. This leakage is so large in amplitude that it will completely drown all the signals that you should have heard from the reflections. We are working on how to solve this. At UWB, we have a wavelength of about 7.5 centimeters. So we need a multi-antenna system here with the transmitter being 2 or more antennas. This is still work in progress. I do want to show you a few implementations that we have. This is one of the first systems when the student was still at home due to the pandemic, was created in a corridor, and then this was in the lab. The UWB device itself looks like this. It has a buzzer somewhere here, and the UWB chip is basically DKP. Here is a small demo. There is a perimeter being set up. Okay, I'm not sure whether you can hear it. There is audio here. Do you hear it? Okay. All right. So let's just start from here. One last thought. Let me mute this once again. For this central entity with multiple antennas, the final system is going to look like this. This is still work in progress, where we have a 2 antenna transmitter. What we know is if we just have a single antenna transmitter, the direct path is going to drown all the other reflections. These are very weak reflections. But once we have a double antenna system, which kind of cancels out the signal, we now start to get much more amplitude on the reflections themselves, which will allow us to eventually detect intrusion in the reflection part. Right, so let's move directly to the conclusion. We are just getting started. This is not a product. This is, even if I placed it as if there are like 4 different products, it is not. We are just getting started, but I think it is possible to use wireless sensing and create disruptions in the physical security industry. Right, at this point, I will stop and I will take any questions. Thanks.